Video and audio working fine?
Yes, sir. Okay.
Yes, sir.
Yes,
Okay, all right.
Yes, sir. It's working fine.
Okay,
The first one is fix or observed position. And this is the position of a ship that is obtained by intersection of two or more position lines, intersection of two or more position circles, intersection of one position line and one position circle. I'm sure you would have watched the earlier videos on position lines and position circles.
beta, we have done the position lines. Position circle I am doing after the application of wind and current. इसके बाद हम position circles भी देखेंगे, different methods. So,
and would by now be comfortable with the concept of PLs and PCs, or a position that is obtained by a reliable electronic navigational aid like GPS, which may provide the position in its coordinates of latitude and longitude. A fixed position or an observed position is a confirmed or validated position. It's represented on the chart with a symbol of a dot and the circle surrounding it. The dot in the center represents the position of the ship. And if we want to indicate the time for which the fix has been marked, it can also be indicated against the symbol, as you can see on your screen out here.
so any doubts up to here, beta?
No, sir.
Very good.
The next one is DR position or the dead reckoning position, which is obtained by factoring in only the ship's displacement caused because of the course she steered and the engine distance that she has covered from a last known fix. So to mark the DR of the vessel, we must know the last known fix. We must know the course or courses steered during that interval since the last known fix and the engine distance that has been covered. DR position on the chart is represented by a cross. And if the time has to be represented for the DR, it can also be marked next to the symbol. DR position does not factor in effect of any external force like current or wind experienced by the ship.
Okay, so this is regarding the dead reckoning position. Any doubts up to here? Okay, let's
No,
proceed
sir.
ahead. Okay,
The next is estimated position. It is the position obtained by factoring in ship's displacement because of the course steered, engine distance covered, together with the estimated current and or wind that may have been experienced by the vessel during that interval. EP on the chart is marked with a triangle or a square with a dot in the center. And if the time has to be indicated, that can also be mentioned against the symbol. EP factors in the estimated effect of current and wind experienced by the vessel. So now, amongst all these, undoubtedly, an observed position or the fix of the vessel is the actual position of the vessel that has been observed by definitive position fixing means. Next in the order of accuracy would be the estimated position, and last would be the DR position. We shall be using these positions depending on the information that is available in the same order of accuracy. If we have a choice, fix would be of the first topmost priority, followed by EP, and if none of them are available, we would use the DR position. Now let's understand the effect of current on the ship's track. What is current? Current is a continuous directed flow or movement of seawater because of varied causes like difference in temperature, difference in salinity, etc., etc. The moving seawater causes the displacement of objects floating in it as it carries them along. So the floating objects, which are freely floating in water, would be carried with the water as the water flows because of the current. In the absence of any external factor like current, ship's drag or displacement over the ground shall be same as its displacement through water. So we must understand the difference between drag through water and drag over the ground.
Beta, is this clear? Any doubts up to here?
No, sir.
Okay, all
सर
right.
ये लिखा है कि ये the ship's drag over the ground is same as through the water in the absence of current. इसका मतलब सर अगर ये करंट नहीं होगा तो जो अपना dr होगा dr that will be over the ground, ऐसा है क्या?
नहीं बेटा, इसका मतलब ये है कि अगर कोई भी करंट नहीं है, एक्सटर्नल फैक्टर कोई भी नहीं है, तो जो आपका dr पोजीशन है वही आपका एस्टिमेटेड पोजीशन भी होगा।
तो ये थ्रू वाटर और ये ग्राउंड का क्या मतलब है यहाँ पे?
ओके बेटा, ओके बेटा, अभी हम देखेंगे जब हमारा शिप जो है ये चलता है तो हमारे दो तरह की डिस्प्लेसमेंट होती है। वन इज डिस्प्लेसमेंट ओवर ग्राउंड, जिसको हम बोलते हैं कोर्स ओवर ग्राउंड एंड स्पीड ओवर ग्राउंड, और दूसरी डिस्प्लेसमेंट होती है ओवर वाटर, जिसको हम बोलते हैं कोर्स थ्रू वाटर और स्पीड थ्रू वाटर। ओके, सो अगर कोई भी एक्सटर्नल फैक्टर नहीं है तो हमारा स्पीड थ्रू वाटर एंड स्पीड ओवर ग्राउंड विल बी द सेम, और कोर्स ओवर वाटर, कोर्स ओवर ग्राउंड विल बी द सेम। देयर विल बी नो डिफरेंस इन इट। इन दोनों में डिफरेंस तभी आता है जब कोई ना कोई एक्सटर्नल फैक्टर हमारे शिप पे एक्ट करता है। दिस इज द मीनिंग। ओके, अभी हम देखेंगे कि हमारा कोर्स थ्रू वाटर क्या होता है और कोर्स ओवर ग्राउंड या कोर्स मेड गुड क्या होता है। अभी आएगी ट्रायंगल।
ओके
ओके,
Track over the ground. Now, let's understand this thing through this simple illustration. We have a vessel which is at position A at 0800 hours. It steers a course of 070 degrees true at an engine speed of 11 knots. There is no wind, no current, and we need to plot and obtain the dr of the vessel and the fix of the vessel at 1000 hours. So we plot the 0800 hours fix on the chart, as you can see. Now, from the last known fix, which is 0800 hours, if we apply the ship's displacement vector because of our own propulsion, that is the CTS and the engine distance, that shall give us the dr, as we have already discussed under the dr explanation. So from A, we draw the CTS of 070 degrees true. In chart work, the CTS is always marked with single arrow, and you please have to respect this convention of single arrow to represent the CTS line. On this CTS line, from A, if we mark off engine distance for 2 hours, which shall be 11 into 2, that is 22 miles, we get point B. Point B is obviously the dr at 1000 hours. Now, as there is no other displacement vector acting on the ship than her own propulsion, obviously her track over the ground would be same as the track through water. What we have plotted is the track through water, and in this case, the track over the ground shall also be the same. So actually the vessel would be at point B at 1000 hours. So this track over the ground is represented in chart work by course made good and distance made good. And this particular vector is represented by 2 arrows. You can see the 2 red arrows coming on the same track. That means track A to B, besides being a CTS track or track through water, is also a course made good track and track over ground. So in this particular case, CMG is same as CTS. DMG, distance made good, is same as engine distance. And this position B happens to be the also fix of the vessel at 1000 hours.
Okay, so beta, did you understand this? There is no wind and no current. Our course steered is the same as course made good. Our estimated position, our DR position, our fix is also same at point B.
Yes, sir.
Yes, sir.
ओके, वेरी गुड। अब बेटा इसमें धीरे धीरे और चीज़ें इन्वॉल्व करते चले जाएंगे। करंट को इन्वॉल्व करेंगे, फिर उसके बाद विंड को इन्वॉल्व करेंगे, एंड वी विल सी हाउ डज द शिप बिहेव।
Position B is both DR as well as fix. Then we have track through water, which is represented by CTS and engine distance. And we have track over the ground represented by CMG and DMG, though both have been same in this particular case. Now, before we discuss the effect of current, we need to understand the terms that are used to describe current. The direction of the current is represented by what is called as set. Set is the direction in which the water flows. That is, if we say the current is setting south or current is setting 180 degrees true, that means the water is flowing from north to south. The rate of current is the speed of current. It is expressed in knots. The drift of the current is the distance through which a freely floating object at rest relative to sea water be drifted in a given period of time because of the current. Obviously, the drift, if we have to obtain in a certain period, it shall be equal to rate of the current in knots multiplied by time in hours, and what will get drift shall be in nautical miles.
So beta, is this clear? Any doubts up to here?
Okay, sir.
Okay, great.
Now, with these terms having been discussed, let us look at effect of current on the ship's track. When the vessel steams, vessel experiences the displacement vector because of her propulsion, and this displacement vector because of her propulsion acts both through water as well as over the ground. And this displacement vector is represented by course to steer as its direction and engine distance as its magnitude. If this vector is applied to the last known fix, we have already discussed this, it shall give us the vessel's DR at the end of the steaming period. If the ship also experiences current, an additional force vector is caused, represented by set and drift during the interval. This additional force vector, because of the current, causes displacement only with respect to ground or over the ground and not through water, because the water and ship, they flow together or drift together because of the current, and so there is no displacement of the ship in relation to water caused by the current. Thus, ship experiences two displacement vectors over the ground. Its track over the ground shall in such cases be along the resultant of the two vectors.
So beta, just have a good look and let me know any doubt in any of the points. Okay, let's move ahead now and apply these on the chart.
Let's try to see what we have just discussed through a simple example. We have a vessel at position A at 0800 hours. You can see on your charts. It steers a course of 070 degrees true at an engine speed of 11 knots. The vessel experienced current setting south at 3.8 knots. Now, by plotting, we need to obtain DR and fix. We have already seen in one of the earlier examples wherein there was no current or wind, the DR and fix at 1000 hours happen to be same. Let's see what happens in this particular case. Now, through A, if we plot our ship's displacement because of our propulsion, then that will be CTS drawn through A, represented by single vector, distance marked off for 2 hours 22 miles. Position B, this becomes the DR of the vessel at 1000 hours. This we have already discussed earlier as well. Now to see how does the current affect the vessel's displacement over the ground, for one time at least, let us split this into two distinct parts. Two displacement vectors, one because of ship's propulsion, other because of current, acting simultaneously, but let's assume they act one at a time, each acting for their respective 2 hours. So if only the ship's propulsion vector, CTS, and engine distance vector acts for 2 hours, then the vessel is expected to shift from or displace from position A to position B. So at 10 o'clock, you would expect the ship to be at B. Now, once at B, let us assume the engines are stopped. Ship is in complete rest in relation to the seawater, surrounding seawater. And now the current sets in, setting south at 3.8 knots. Now, as the water starts flowing southwards, the vessel would also drift southwards. So the vessel shall start drifting with over the ground in this direction as represented by the green vector. Now the green vector represented by 3 arrows is the current vector, and this is the standard 3 arrow notation that is used in chart work. If the vessel drifts for 2 hours, then she would have drifted through a distance of 3.8 into 2 equal to 7.6 miles, and she would reach point C. Now that means 2 hours of propulsion vector, 2 hours of current vector, both acting for 2 hours each. We expect the ship to reach point C. So C would be the position of the ship at the end of 4 hours in which both vectors have acted one by one. In our case, both these vectors are acting simultaneously. So both are acting for 2 hours each, but not one at a time, but simultaneously. So the effect would still be the same. And at the end of 2 hours, with both vectors acting simultaneously, the vessel would be expected to be at C. That means from 8 o'clock to 10 o'clock, so C becomes my fix at 1000 hours. From 8 o'clock to 1000 hours, the track over the ground would be represented by line AC. This track over the ground we refer to as course made good as its direction and distance made good as its magnitude. It's represented by 2 arrows. So now in chart work, the CTS vector is represented by 1 arrow, current vector is represented by 3 arrows, and course made good vector is represented by 2 arrows. Now, the direction from A to C becomes course made good, which in this case is 091 degrees true, and the distance or magnitude of AC is 20.6, which is the distance made good. Since this 20.6 miles is the distance made good in 2 hours, so the speed made good would be 10.3 knots. So now please remember in this case that each side of this triangle is for the same duration. Here the engine distance was for 2 hours, drift was for 2 hours. So obviously this DMG would also be for 2 hours. So C is the fix at 1000 hours. D is the DR at 1000 hours. And the vessel's position will shift along the line AC, but her CTS does not change. CTS remains 070 degrees. So you see when the vessel reaches here, her heading is aligned in this direction, that is 070, but her position is shifting along this CMG line. When she reaches here, everywhere the heading is same as 070, but position is shifting along the CMG line.
Okay, so this is the course, distance and current vector triangle beta. So this is a very, very important concept. Now let me know anything which you could not understand. Have a good look at this diagram and tell me anything, any point which is not clear.
सर पॉइंट सी ईपी नहीं होगा सर ईपी
Yeah, it will be EP beta. It will be EP. It will be the estimated position.
लेकिन यहाँ पे सर वो जो साइन है वो तो फिक्स का है ना
हाँ वो फिक्स का बना दिया है बेटा बट एक्चुअली इफ यू स्पीक फंडामेंटली इट इज़ द एस्टिमेटेड पोजीशन सी इट डिपेंड्स अपॉन द सिचुएशन. यहाँ पे दो सिचुएशंस हो सकती हैं बेटा. अभी तो हमने सिर्फ ये ट्रायंगल को अंडरस्टैंड किया है. सिचुएशन कुड बी कि 8 o'clock द वेसल वाज एट पोजीशन ए एंड एट 1000 hours द वेसल्स पोजीशन वाज ऑब्जर्व टू बी एट सी. Okay, now you can make the CTS vector and you can find out the current vector. So अगर हमें current vector को find out करना हो और final position पता हो then in that case it will be a fix. But अगर हमें current पता हो और हम current को estimate करके अपनी final position निकाल रहे हैं then it will be a EP. The emphasis here is to understand the resultant triangle of the vectors. So whether this is EP or it is the fix will be decided by what is given to us in the question. Did you understand beta?
यस सर थैंक यू.
Okay. Any more doubt coming to the mind beta? ओके बेटा ऑल राइट.
सर
हाँ बोलो बोलो बेटा.
सर इसमें हमने ना ये कंसीडर किया था कि 10 बजे हम वहाँ पे पहुंचे तो फिर वहाँ पे वेसल स्टॉप कर गया और वहाँ से करंट लगना स्टार्ट हुआ बट द करंट वाज एक्टिंग थ्रू आउट ना सर.
दैट्स राइट बेटा.
व्हाई वी डिड कंसीडर ओनली देयर मतलब ये कॉन्सेप्ट थोड़ा
ओके
समझा दो.
मीन्स यू आर आस्किंग कि हमने वेक्टर ट्रायंगल बनाने के लिए पहले एक वेक्टर को लगाया और फिर उसके बाद दूसरे वेक्टर को लगाया. एक्चुअल में तो दोनों साइमल्टेनियसली लग रहे हैं. राइट बेटा, इज दिस द क्वेश्चन?
That's right, sir. But the current is acting throughout. Why we consider the vessel is stopped and then current started acting?
ओके बेटा ओके, आई विल टेल यू. देखो बेटा यू आर वेरी राइट कि एक्चुअली तो ये दोनों की दोनों चीज़ें साइमल्टेनियसली ही हो रही हैं. शिप का इंजन भी मूव कर रहा है और करंट वेक्टर भी अप्लाई हो रहा है. बट हमने इसको एक के बाद एक क्यों लगाया? दिस इज़ ए प्रॉपर्टी ऑफ वेक्टर एडिशन कि अगर हम वेक्टर्स को एडअप कर रहे हैं तो उनको किसी भी सीक्वेंस में एडअप करने पे उनका रिजल्टेंट सेम आता है. इफ़ यू हैव टू वेक्टर्स, आप उनको किसी भी सीक्वेंस में एडअप कर लीजिए, उसका रिजल्टेंट जो है वो सेम आएगा. Whether you apply the CTS vector first or you apply the current vector first, the end result is going to be the same. Now, लग तो ये दोनों साइमल्टेनियसली रहे हैं, लेकिन जब हम ये वेक्टर एडिशन को करेंगे तो वेक्टर एडिशन में दो वेक्टर्स को ऐड जब हम करते हैं, साइमल्टेनियसली ऐड करने का कोई मेथड हमारे पास नहीं है. So the actual method which we follow is we first make one vector and after that we make the second vector. उसी से हमें हमारा रिजल्टेंट पता चलता है. सो जो ये ब्लू कलर की लाइन AB और ग्रीन कलर की लाइन BC हमने बनाई है, that is to add these two vectors, not to find the actual track on which the ship moved. एक्चुअल ट्रैक तो इनके रिजल्टेंट के वे में हमें मिलता है, which is A to C. Ship was actually moving on A to C. Ship was moving on this particular track and it was steering 070, which is represented by the blue color arrow. So did you understand this better?
Yes, sir. This is the way of adding the vectors only.
Right, क्योंकि simultaneously add करने का कोई मेथड नहीं है हमारे पास.
Okay, sir.
Okay.
सर ये डायग्राम जो है दिस इज अलाउइंग फॉर द करंट. इफ यू आर काउंटरएक्टिंग द करंट, ये जो करंट का जो लेग है सर ग्रीन वाला, दैट विल बी अप्लाइड एट पॉइंट ए, राइट?
राइट बेटा, दैट यू आर राइट. हम अभी इसके बाद अलाउइंग और काउंटरएक्टिंग दोनों को 1 by 1 करेंगे.
अच्छा, ओके सर, ओके, ठीक है. वो बच्चा है, मतलब आने वाला है सर वो.
यस, अभी तो हमने सिर्फ वेक्टर ट्रायंगल का कॉन्सेप्ट अंडरस्टैंड किया है. अब वंस वी आर फेमिलियर विद द कॉन्सेप्ट, हम लोग देखेंगे कि करंट को अलाउ कैसे करना है और काउंटरएक्ट कैसे करना है, दोनों देखेंगे बेटा.
ओके सर.
ओके, सो दिस वाज द करंट इफेक्ट. हमने सिर्फ अभी वेक्टर ट्रायंगल को देखा है. वी विल बी सीइंग अलाउइंग द करंट एंड काउंटरएक्टिंग द करंट इन डिटेल.